Australia right now is embracing the drone technology in quite a way that we're not seeing before. These things are very lightweight and very low cost these days. And what we're seeing right now is CASA recently reduced its requirements to actually go and fly these lightweight devices as well. Now you don't need a license. It's simply a case of signing onto their website and letting them know that you're going to go and fly a drone over an area. We're seeing that the drone space, though, is becoming very, very crowded. In 2015, here's an icon of exactly the number of companies that are there. In 2016, that number has grown exponentially again. But what we're seeing is that Esri is catering for this. We're basically providing software that allows you to ingest, process, and distribute these data that comes off of these devices to your organisation. Drones really empower you to collect data on your own, low cost and efficiently, and super high resolution, not what you were able to collect in the past. Earlier this year, Esri released a product called DronetoMap for ArcGIS that allows you to streamline this data through your system and make it available. Now, this DronetoMap works with a complete wide variety of drones as well, like this 3DR one, which is a partner of Esri at the moment. It doesn't really matter where the imagery comes from. Now, I can't really fly this in here. It needs 10 GPS satellites to actually take off. All I can do is turn it on. But what I will talk about is we went with our client, Beach Energy. They're in the Cooper Basin, and as you can see from this, in the far northeast of South Australia. Beach Energy is a premier oil and gas extraction company, and their actual sites are very detailed, very small, but compared to their lease, which is a very large area, they have a need to capture imagery over that zone. When you do fly aerial missions over there, you find that the aerial missions are large, of low resolution, and they're captured intermittently. What this means, though, is that they don't have very good information of their installations when they build new ones. So enter the world of the drone. They're able to put up the drone very quickly and fly it. I'll just take you through a quick time lapse of how we actually capture imagery with a drone. You'll see very easily, this is the drone we used, simply putting on the propellers, setting up the battery. A very simple, easy process, no hardware needed. You just find a location where it's clear, and then on the software that comes with the drone, you simply draw a polygon of where you would like it to fly. The software works out the rest for you at the resolution you want. And then you simply say, go. That's how easy it is. The client, when we went up there with Beach Energy, they expected us to do this in 3 days. We did it in half a day, most of the flying that you see. It then takes off, navigates to the area at once, gives you a relative altitude over on the left-hand side here, and gives you an instant view of what the drone's seeing on the top right there. Every time it snaps, it takes a photo. The software is calculated and worked out in such a way that it gives you a 60% overlap in the forward direction and 70% overlap in the sideways direction. What that allows you to do is create beautiful, high-resolution, seamless imagery. I think one of the most amazing things with this is my son, who's 8, had to go with this drone, and he was able to fly it himself. That's how simple it is, the technology today. So anyone can actually work with this. When it finishes, it just goes home, comes back to where it took off. And you'll notice when it starts to land, I had no control in this at all. It just basically lands itself. But that's only the first piece of the exercise. We need to then take the SD card out of the drone and pop it inside the laptop. From there, it's where DronetoMap comes into play. It takes all that imagery and finds thousands of geolocated points and matches through the images itself and provides seamless GIS-ready products for your organisation to use. It gives you large tile services that can be served in the same day that you flew the imagery. That's what's so powerful here. You can put it up and visualise that the day you flew that imagery. If you hang a fourth band infrared underneath there, you can be performing visual infrared analysis and finding out where the healthy vegetation is in your environment, same day. You can also produce beautiful high-resolution digital elevation models of your areas of interest. That enables you to get information into engineering packages or produce surface models and flow analysis. As a product also, we get high-resolution 3D colorized point clouds. Take that into the engineering packages and look at how things are built compared to the way they're actually designed. And then publish 3D textured meshes out onto your web for the whole organisation to get a look at. Let's take a quick look at then some of the imagery we captured. Oops. Each image we capture is rectangular in nature. And if I go and have a look at one of these, you'll see the GoPro camera that we have on this gives you a very fisheye type look. So what you need to do is be able to flatten this out. Also, if we start to zoom in on this, you can see that it's 1-2 centimetre resolution imagery, super high resolution. So we go into DronetoMap, and there's three or four projects here, and what it allows us to do is decide exactly the way we want to process this imagery. We do a rapid project, we're out in the field, I can quickly look at it, and I'll talk a bit about that in a minute. 2D or 3D mapping projects, and then an inspection project where you might want to go around an object. So let's just go and set up a 2D mapping project. Just simply give it a name, and then where that information comes from. And you'll see it reads all the imagery in that folder. It takes the X and the Y information from that image and the altitude of what the drone was flying at. Simply put, that's the minimum requirement that you would need to build a drone project. What does it give you? Well, as you can see from this view here, it gives you a flight path of where that imagery actually flew. And we can get access to any of those images and visualize those. Again, inside the desktop DronetoMap environment. Now, one of the key things with this is that had an X and a Y and a Z allocated to it. So it's using the GPS. But as you know with GPS, that's relatively plus or minus 5 meters. So what you can do is you can take the ground control that you've collected out in the field and use that to tie down the images to their correct location in the real world. Using the information that's captured against the photos, DronetoMap also calculates the flight path that was worked with as well. You can see here that I actually have 3 flight paths in this. We used that rapid inspection project in the first instance and found that we didn't have enough coverage over some of those tanks. So what it's done was we've included another 2 projects to give us a better resolution, better detail. We then simply choose the processing options that I'd like to work with. Now, the beauty with DronetoMap is what it allows you to do is not even have to enter this page, because depending on the project that you choose, it presets a lot of these options. But if you want to fine-tune it, you can go through and set up how it measures those key points, how you flew it, how you would like the point cloud to be generated, the formats that you might want to use it, so whether it's going out into some sort of engineering package or whether you want to take it into another 3D package. And then with your aerial photography that's coming out of this, what type of resolution do you want? Do you want the optimal resolution? Do you want the finest resolution you can get? And then how smooth you want that surface to be. If you happen to have a 4th band, then you can go and do an NDVI vegetation analysis against that as well. DronetoMap's designed to take use of the much resources that's available on your computer, and you can specify basically here the number of CPUs that you would like to use. Now, once I've all set that, I can go and hit start. With this particular project though, that would take about 3 hours to run. So I'm not really going to run that here today. What I will do is give you an idea of the results that come out. If you think back to those images I showed you a moment ago, they had a strong fisheye associated with them. I have a look now. I'm now looking at a flat, seamless image that I'm able to start work with and analyse. This is not achievable with aerial photography, but it's not a substitute for aerial photography, it's a supplement to it, to increase the resolution in those very specific areas. Also, 3D view, I can get a nice textured mesh, and we can visualise that in 3D of exactly what the installations are like and view that. But as I said before, we can get other products out of this as well. I'm just going to switch over to ArcGIS Pro now. In this instance, I've enhanced that image that I brought out of that. I'm just going to go and zoom in and start to look at the detail of this imagery. And you can see right the way down to the flanges there. I can then start doing accurate measurements off of this and recording against that and using that in my field work. But one of the things I said before, it gives us a precision elevation model. And looking at this area here, you really can't see there's much elevation associated with it. Beach Energy were very keen to understand where all of their elevation is and where their berms and where their flood zones are. One of the keys with this is located right next door to the Cooper Creek. So if they have any spillages, they have to contain them very quickly. And you can see exactly where the berms are, where the banks are for their settling ponds, and where various installations are through that environment. Moving over to another area that we flew for them, it looks like it's fairly featureless. But what we actually see here on the screen is an area that they call a borrow pit. It's where Beach Energy extract soil for maintenance of their roads and what they call their laydown areas, which is areas where they put in their oil rigs and run their tanks across. Now, when we have a look at that in some detail, you can see exactly where that depression occurs. Now, there's not one of these for every oil extraction facility. There's 800 through their lease. Beach Energy is going through now with the drone and calculating the volume of all of their borrow pits so they can work out how to do the remediation after they leave these areas. And that's one of the key things here is it gives you the technology to be able to, using ArcGIS, to be able to find out exactly how much information is required to put in there quickly. Now, many of you would remember that South Australia had some flooding instances recently. One of the things here is this soil around here is very sandy and very clay. But what we can see is very quickly we're able to identify areas of erosion. Up here, they need to fix these very quickly. So when they have flooding events and storm events, they can put the drone up and identify areas of erosion very quickly and very easily and go out and remediate those. Now, as I said before, it puts out a high-resolution point cloud. And this is one of the things that Beach Energy was very keen to get a hold of because they have in their engineering packages the design of all the tanks. What they don't have is the actual as-builts. One of their key intentions was to take these point clouds and put them back into their design packages after they've been completed. Just going back now to DronetoMap. One of the key things I said earlier on in the piece was that DronetoMap allows you to share with your organisation the same day. It has these tools here to create tile layer packages and scene layer packages. It takes the imagery that you've processed, publishes a tile package, and publishes it to Portal or ArcGIS Online. Here I have a web map of what I produced before. It's now in a web map environment, but what I've done is I've put all the imagery that I collected for that particular sortie that we did with this. And so you can see here is another area that we went and visited with them and gave them the resolution that they need to actually look at that. And then also the camp as well, where they actually stayed. And you can see the difference between the surrounding imagery and the actual installation now and the resolution they're able to get at. It's imagery that they've never had access to before that they're now actually able to start using. And finally, publishing it into a 3D scene, we're able to visualise that in ArcGIS Earth and see exactly where that data sits and its relationship to the surrounding environments. We can see it in its full 3D capability, and we can start to basically pan around and zoom, see exactly where all these installations are and what's going on there. So, going back then, DronetoMap is purely a standalone application, no ArcGIS involved. You can run it on a laptop, you can run it on a server, doesn't matter. It works with any type of drone. This is just an example of one of our partners' drones. The minimum requirement is that you have X, Y, and Z associated with imagery, and DronetoMap will work the rest out for you. It outputs the flight information, the centers of the imagery, as well as the flight path, and creates high-resolution, seamless mosaic data sets that you can work with throughout your whole organisation. Intelligent surface models that you can use for performing analysis, and high-resolution point clouds at full colour as well. DronetoMap is providing you tools now to integrate your drone data with your ArcGIS environment. Thank you very much.